Woohoo! We are live, and this is Math 75, and this is a problem from Chapter 2. We're working with profit and quadratics and break-even points. So here we go. Here's a problem. Given the following, the price per unit is $44, and the cost function for this unit is 2x squared plus 20x plus 70. From that, I'd like you to find the profit function, P of X, and then graph it. And on the graph, label the point of maximum profit and the break-even points. Woohoo. So let's get into it. So the first thing is if we're going to find the profit function, we're going to have to find the revenue function. So that's the first step. So I'm going to look through and I see that it says the price per unit is $44 right there. So that's going to help me find R of X, which is the price times the output, which in this case is 44x from what's up above there. So that's the first thing. Okay, and then to find the profit, again, revenue minus cost. And now let me point out, because a lot of people make this mistake because you get very excited and you get into the formula and you forget the parentheses. So the revenue is 44x. But if you just write minus and then 2x squared plus 20x plus 70, then you're going to miss a bunch of what should be subtracted. You need to subtract the entire cost. Right? So use parentheses whenever you subtract something that has more than one term. So I've got 44x minus 2x squared minus 20x minus 70. And then if I rearrange, noticing that I've got two x terms right there, I can get negative 2x squared. 44x minus 20x is plus 24x minus 70. So there we go. Okay, so there's my profit function. Woohoo! So for the profit function, I found it. There we go. It's right here. There we go. Okay, and then I have to graph it. So in order to graph the profit function, I'm going to have to come up with a bunch of different pieces of details about profits. That's why I've got my calculator at the ready. So the first thing I'm going to do is write out the formula. Negative 2x squared plus 24x minus 70. Okay, so I happen to know right off the bat, this is a parabola. Is a parabola that opens downward because of the minus sign right there. Because of that minus sign, we've got a sad parabola, right? Basically, you can draw the eyes in. It's a sad face. If this x squared had been a positive, had a positive coefficient, it would be a smiling parabola. So this is a sad parabola. And so I know there are a bunch of points that I can find. One point would be the vertex. And this just has to do with the formula. The vertex is given by the first part of the quadratic formula, the opposite of b over 2a, which is the opposite of 24, all over 2 times negative 2, which is the opposite of 24, all over negative 4, which is 6. So when x equals 6, we're at the very top point of the parabola. So that's going to give me my label the point of maximum profit. This is half of that point. Now I need to find what the y coordinate is. So plug in 6, I get negative 2 times 6 squared plus 24 times 6 minus 70. So negative 2 times 6 squared plus 24 times 6 minus 70. Most calculators will let you just go ahead and type it all in. Let's see if it worked, because I know what the answer is. Woo, that worked. And then everyone looks at me like, are you kidding? The profit is 2. And here's the thing. Given the kind of parabolas that are reasonable to graph, given the other requirements of the problem, we end up with these kind of weird situations where the maximum profit you can make is 2. If you'd like, you could imagine that the profit function is actually given in millions of dollars, so you can make $2 million, or you can realize that most businesses don't actually make profit. They just meet their costs, and in a good year, maybe there's some extra money, but a lot of the time there isn't extra money. Businesses meet what their costs are. They pay everyone their salaries and their wages, and they pay all their bills, and that's considered a good day. So you can choose which one you like. You can either go with it's 2 million, or you can go with there just weren't very many profits. But I do have the 0.62 on the graph. I also have another point. So here's the vertex. Woohoo. I can find the y-intercept. That's the one that happens when x equals 0. P of 0 equals, well, it just equals whatever this is. And if you take out all of the x terms, it's whatever the constant is. So I've got the 0.0 negative 70, which I'm thinking, oh my goodness, this is going to be miserable to graph. But that's a circus for, 5 minutes from now, because I've got one other thing I need to do. And the one other thing that I need to do is I need to find the x-intercepts. I need to find out what happens when y equals 0. So I'm going to set the whole profit, negative 2x squared plus 24x minus 70 equals 0. Now here's the thing. This does factor, and it factors fairly nicely because I designed this to be not too terrible a problem. However, I'm going to assume that most people are not going to be as good at factoring, and so calculator at the ready, I'm going to go ahead and use the quadratic formula. You're welcome to factor if you know how, but the quadratic formula will always work. This one, the opposite of b plus or minus radical b squared minus 4ac all over 2a. Okay, so let's see. That's the opposite of 24 plus or minus 24 squared minus 4. Oh, I didn't leave myself enough room. Times negative 2 times negative 70 all over 2 times negative 2. Okay, so if I multiply this all out, negative 24 plus or minus 24 squared is actually one of the ones that comes up a lot. It's 576. And if you do a lot of math, you'll just memorize that. I've got 3 minuses, so this is a big old negative. 4 times 2 is 8, times 70 is 560. Or you can use your calculator, all over negative 4. Okay. So then, oops, move you guys sideways. So let me leave that up there for a second so you guys can look at it. So I'm just working through the quadratic formula. And I'm going to mark this as page 2 and this is page 3 so they don't get confused when I go to scan them. The next thing I've got is negative 24 plus or minus, oops, everything is a little squirrely, 576 minus 560 all over negative 4. So that's negative 24 plus or minus, and this one is nice. A lot of them don't turn out this nicely, but again, I wrote this one to be nice. Inside the radical is 16. So I've got negative 24 plus or minus 4 all over negative 4. So I've got negative 24 minus 4 over negative 4, or negative 24 plus 4 all over negative 4. So I've got negative 28 over negative 4, which is 7, or negative 20 over negative 4, which is 5. So I know I have the 2.70 and 50. So between these two pages, I know the shape. I know the vertex. I have the y-intercept and I have two x-intercepts. And those 1, 2, 3, 4, those 4 points are going to be enough to graph. So let's go to a graph. And what I will do up at the top, because I don't have enough room on this table to have all the papers out, I'm going to write p of x equals negative 2x squared plus 24x minus 70. And then we're going to write in 0, negative 70, 7, 0, 5, 0. And then the other one was 6, 2. Okay. So go ahead and take these notes and put them aside. Woohoo. Woohoo, woohoo. So now I have to graph this bad boy. Oh, and I know it's one of these. I know it's a parabola that goes down because this is, see how it's a sad face? It's sad because that number in front of x squared is negative. If this had been 2x squared, it would be a smiley face. It would open the other way. Okay, so generally speaking in business, when we're talking about x as output, we're not going to look at output being negative because that would take a while to figure out how to define it. So my y-axis is going to be almost all the way over on the left. I have to get up to positive 2, but down to negative 70. So my x-axis is going to be way up here too. So I'm really focusing. I'm really focusing here on the fourth quadrant. So here is x. Now you can label this p of x, or you could just label it y. Both are acceptable. In the x, along the x-axis, I think 1, 2, 3, 4, 5. There's 5, 6, 7. I think labeling and using a scale of 1 square is 1 would be fine. The problem is if I counted 1 for 1 going in the y direction, I would never get down to negative 70. And in fact, I don't even have enough squares to do 2. So I'm going to do 4. What does that mean? Like that would be negative 4 and then negative 8, 12, 16, 20, 4, 8, 12, 16, 20, 4, 8, 12, 16, 20, 4, 8, 16. I believe that is negative 76. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes. And then this would be negative 80. Wait, did I do that right? 60, 64, 68. Oh, sorry. You're right. I can hear you through the computer going, wait a minute, that's not 76. That's 72. Thank you, guys. I jumped the gun. I went a little too fast, a little too far. There we go. This is why you always double check. Okay, 1, 2, 3. This is negative 72, negative 76. There's negative 80. Thank you, guys. Thank you for thinking hard thoughts into the computer. That helped me know that I was getting it. I was a little bit off. So right here, I've got negative 68. I need to get to negative 70. I need to get this point. So I'm going to estimate it with my eyes about halfway. Okay. And then what I could even do is I could even put in, I can write in that this is 0, negative 70 right there. I also know that I have a point at 5 and a point at 7 on the x-axis. And then since I'm counting in 4s, this 6, 2, which is right here, is going to be about halfway up. 6, 2 is going to be right there. Okay, parabolas, really hard to do. Personally, I, as a right-handed person, have an easier time kind of doing the curve down. And then to go to the other side, remember that we've got this symmetry, so it's 6. There's I'm going to do a little line there so I can remember. There's x equals 6. So if I go 1, 2, 3, 4, 5, 6 points to the left, then 1, 2, 3, 4, 5, 6 points to the right gives me that mirror point. And then I can pull this, rounding off the top, I can pull it down. Now let's look at the distinction between the two sides. First off, oh no, I smeared. Oh no, oh. So much for me being perfect, eh? Okay, that's okay, because starting off a day being perfect is just too much pressure. So the first thing you'll notice is that I have the point here, no arrow. But on this side, I have an arrow. And that is because X can keep getting bigger. So you can keep selling more and more of these things. What's going to happen? Well, to sell more and more of them, you're going to end up either driving your costs so high or your profit, or your price so low, your profits are just going to sink. Now, does anyone do that? Yeah, sure. A company like Costco with their chickens, or Walmart or Kmart in the old days with their blue light special, you can have something called a loss leader. And that's something that you're going to sell a lot of to get people into the store, something exciting, or maybe even like on Black Friday when they sell televisions that should be like $2,000, but they sell them for $100 just to get you in the store and get you excited. So might someone be operating down here where the profit is really negative? Totally. To get you in the store, to get you to buy other stuff, they might operate down here. What about over on the left? Well, again, as I pointed out, here's the point where x equals 0. Technically, the parabola does continue on over here where x is negative, but there's no meaning to this with an application. So I stop the parabola. So the parabola, rather than looking like this, actually looks like that, if that makes sense, because it's going to stop on the left but keep going on the right. Okay, so let's take a look at what we've got. Our break-even, sorry, don't mean to shine at your light in your eyes. Our break-even points are right there. Those are the points when the profit is 0. So you can see right there, those are your break-even points. And this point, the vertex, is where you get your maximum profit. That's it. P of 6 is 2. So your profit will never go over 2 in this situation. And at which point you might ask, well, of those 3 important points, they all have a meaning. So this must have a meaning. And the answer is yes. Generally speaking, this is the point where you realize your fixed costs. So if X is 0, that means you're not in production yet. You haven't made anything. And what is your profit? Your profit, when you haven't made anything, is negative. And those are generally called your fixed costs. Or we could also have the discussion about startup costs, which in some situations are separated out. Like fixed costs can include startup costs, but you can talk about them in different perspectives. So you might hear them talked about in either way. Basically, when you start your business, before you've actually started selling anything, you're going to have to borrow some money to get your equipment. Perhaps you're going to start with some rental or some other stuff. You've got to get the space. You've got to get some of the materials. So this could be any and all of those things, whatever you need to start your company before you've actually started making anything at all. So there you go. And if we look at the original problem, find the profit function. I did. Graph it. Woohoo. On the graph, label the point of maximum profit. Maximum profit is 2. And the break-even point's right there. And in fact, we even have the fixed costs or startup costs. What do you guys think? Woohoo. Hopefully that was good. Hopefully life is good. Hopefully you guys are having a great time learning math. Woohoo. Math on, guys, math on.